Now, a note to everyone, this is Criterion 8, right? Redox titrations. Because it's a calculation. But we're going to use some of our redox theory now that we need to know for this series of titrations. So we know that volumetric analysis is a way where we can determine quantities, and it's all in solution. So if we're working in solution, what are our important relationships?
Concentration.
Yeah, C equals N over V. And what's the other way we often see this rearranged?
N equals CV.
Yeah, N equals CV. And really common mistake, getting this round the wrong way. Okay? And like I said to you before, I don't necessarily have a lot of sympathy because it's on the formula sheet. Okay, you only have to copy, so you don't have to memorise. Now, this reaction is quite similar to what our practice that we're going to be doing. So it says here, to analyse the iron content of a sample of steel, we first dissolve the sample in acid. Okay, so we're starting out with solid iron, and then we have to react it with acid. And what happens when we react a metal with an acid? So what's our product?
Gas.
What gas?
Hydrogen.
Hydrogen gas. Okay, so it's the same reaction as we've looked at a number of times, even from fissile when you did the POP test, magnesium in acid, but this is what reactive metals will do. We need the acid to be reasonably concentrated for us to be able to do this reaction with iron, and we also just want the Fe2 plus ions, and they won't stick around for very long if it's just in water anyway. Okay, they continue on an oxidised Fe3 plus. And we have our permanganate half equation as well. Well, so this is the step that we need to do to get the Fe2 plus ions. Then we react them. We react the Fe2 plus with acidified permanganate. And we produce Fe3 plus, manganese ions, and water. And that's not balanced. How would I go about balancing this?
Wrote out the half equations.
Yeah, the half equations. So I might start with this one. What's happening with this one? What is it?
It's losing.
Losing an electron, so what kind of reaction?
Oxidation.
It's oxidation. And so our electron goes on that side there. What do I need then for my next half equation? Which ones will I be picking out? MnO4 minus, and we need something that's got the manganese in it, don't we? This has to be reduction, doesn't it? Because we've already got oxidation. So what are we going to be looking at to make sure that we've balanced it correctly when we're doing this process?
Oxidation states.
Oxidation states?
The amount of electrons.
Electrons. Yeah, well, we're going to want to make sure our electrons are where?
On the left side.
Yeah, on the left-hand side. So let's have a go. What is the first step of balancing a redox? equation. Sorry?
Balance oxygen.
Before we even balance the oxygen.
Make sure everything else is
Oh. So
equal. So like
Yeah.
everything.
So balance our anything that's not hydrogen or oxygen, which we didn't have to do in this case because it's 1-to-1, but it's something we have to think about every time. Okay, because that's an easy one to get tripped up on. What's our next step then?
the oxygen.
Which we balance with water, and so we need 4 waters. And our next step, hydrogens. And then our last step, electrons.
So 1 plus 2. So 5.
Yeah.
5 electrons. Yeah. Okay. And then we know that when we want to bring these together to be a full redox reaction, what do we need to do for that last step?
Oh, multiply. Get the same amount of electrons.
We're going to multiply that one by 5, aren't we? Yep. So we've already got it written up here. I can put my 5 there and my 5 there. And I need an 8 here and a 4 here. And then it's balanced, which is what was written in the booklet. But we do need to make sure that we're really clear on this process. Now, we can't just titrate with the permanganate, but we can't do that to start with. In actual fact, permanganate's a little bit difficult solution to make up, and Andy has to filter out solids that occur when she's making up the solution. And so we are back to needing a primary standard again. What's the function of the primary standard? Now, if we think about what this series of titrations will be about, is what we want to find is the percent iron in steel wool. Okay, that's the aim of this series of experiments. So we're going to dissolve the iron in acid, and then we titrate it against the permanganate, but we don't accurately know the concentration of the permanganate solution. So what is the purpose of the primary standard? To what?
What concentration of the permanganate?
Yeah.
Yeah,
So
every answer I've given so far is pretty wrong.
I like the upward inflection. I don't really know what I'm saying. Yes, we need to standardise this, okay, because we don't accurately know. We know an approximate concentration, but we don't know it accurately. And so that is the function of the first set of titrations to standardise the permanganate. Do you remember what is needed in a primary standard? What properties are needed in a primary standard?
It doesn't react in the atmosphere.
It's easy to obtain.
It needs to be available at high purity.
Yeah.
It doesn't absorb moisture in a solid.
Goes with it's inexpensive.
And pure.
Yep, so there are some important points. There's one that's left out.
We have a high
Reaction.
mole in it.
Yep. The high molar mass will help us with our determining our values for our titrations with a higher accuracy. Okay, and so what we are going to be using is sodium oxalate. Just going to rub this off. Yeah. Oh, we'll just so turn the page. Let's go through this one together as well.
Oh, the answer to the
Just check what I've got in here. The right thing.
What is it? Sodium.
Wait, so it's sodium oxalate, Na2C2O4, is it? Now, I'm not really interested in one part of this. What part am I not interested in? No, that's the part I'm actually
not interested in the sodium.
Yeah. Because what kind of bonding have I got
In
here?
a row.
Ionic. What can you tell me about sodium in solution? All soluble. All sodium salts are soluble in solution. So, can I reduce it in solution? No, I cannot. So what do we call something that's there but doesn't do anything?
Spectator.
Yeah, spectator ion. So we're not really interested in this one. So what I want to look at is a redox half equation then for the oxalate ion, and I can tell you that it produces carbon dioxide. So if it produces carbon dioxide, let's balance this one. What's the first thing I need to do?
Balance the sodium.
Yeah,
Oh,
we need a 2 there, don't we? Okay, this is where things don't work out so well if we forget that step. Now I've got one thing missing up there. What is it? No.
Electrons.
Well,
well, that's balance.
yeah, the charge. Where's the charge go?
Oh, is it 2 negative? 2 negative? Is that another
Oh, yeah.
one?
Oh, fair enough.
Yeah?
Yeah.
So now, where do our electrons go?
On the right.
On the right.
Right.
All right.
Why has the book got...
Oh, we're using oxalate, not
Depending whether this is sodium oxalate. If you've got it acidified or whatever, then you'll have H+ ions, but we don't have it acidified.
So why is that acidified oxalate acid?
That's like a different thing you can use.
Supposed to sound.
We can, it will be acidic when it reacts with the acidified permanganate.
So what is the crystal?
It says other suitable primary state.
Yes,
So
that's
those are
right.
just other
So that's
than-
another one that you could use.
Oh, alright.
But there's also like
Okay?
potassium hexacyan.
Okay, so we're all good with that so far? Yeah?